Hey everybody, welcome to Mammoth Interactive's YouTube channel. First of all, I want to thank you for watching this video. And remember that this channel doesn't do Patreon. Instead, we sell our digital courses down below. And every single dollar that we get from the products you buy below goes into making more content. The best way to help out this channel and Mammoth Interactive is to subscribe to Mammoth Interactive's huge library of content. Get thousands of hours and hundreds of courses for a low price down below. We have a monthly option and a yearly option. Thanks for listening, and I'll see you in the video.
Since we are making a portals game, one of the most important elements in this is to actually create the portals. And in a few games you might want to use any surface you can imagine to spawn a portal. So you could use the ceiling, you could use the door, you can use the floor, but sometimes that's not desirable. Okay, we need to limit the area that we are going to spawn portals. And to begin this game, we're going to work on making portals on the walls, okay? Not on the door as the door moves, but we're going to make only on these walls, so we're able to test the basic functionality and then spawn the elements. So the first thing that we have to do is to define the areas where we can spawn these portals, and to help us with this it would be interesting to make a prefab. So if we select one of these walls, okay, I'm going to select this first one here, and if we right click on it and we select create empty, we have an empty game object inside of the wall in the hierarchy. And if you press add component and choose box collider, you're going to have a collider the same size as the wall that we created. Okay, so this is how this collider is looking like. So a good practice here is to make the box collider that we have here to have a size different than 111, okay, because it will be taking the entire wall, and we might want to add a little bleeding area, a little tolerance from these corners. Okay, so let's try 0.8. Okay, on X, no, X could be 1, but Z, let's try 0.8. Okay, we can already see a little bit of the wall here, so maybe 0.9, and Y 0.9 as well. Okay, so it feels a bit better now. It's taking a better area of this. And on X we can increase just a little bit more, just so it comes out from the wall a little bit. Okay, so it's going to look like this. Now you're going to notice that this wall that we're making, okay, this collider that we made, is from the same wall, so it's going to clip through the wall that we recently added. So a good thing that we should do here is to divide this wall into two parts, one before this division and another one after the division. So to help us with this, we're going to use this tool for resizing. So I'm going to grab, remember I'm working with the wall game object. I'm going to drag this and put it more or less here. Okay, it should be fine. Then we're going to duplicate this wall, and to finish the other side we can grab it from here. Okay, so we're going to flip it. It's going to look like this, and I'm going to bring this one a little bit more to this side. Okay, so we're going to have these walls here. Let me bring these one closer to this place here as well. Okay, so there we go. We have the same feeling. It looks like we have only one continuous wall, but we now have two, and we have a better division of these collision areas. Okay, I need to bring this one a bit more to this place so we can see this square, right? And now that we have this game object, we need to give a name to it. So I'm going to name this portal area. Okay, and this box collider needs to be a trigger collider because we're going to perform some tests here later. And it's going to be interesting to have a script. We might not want to use it right now, but it's going to be useful later. So I'm going to right click in the scripts folder, select create, then C# script, and I'm going to rename this as portal area. So we hit enter to save it, and I'm going to drag this portal area in here to apply to the game object. So we drag and drop, and there we go, we have this portal area. And we have to do more or less the same thing for all of the other elements. So a good thing to do right now is to transform this portal area into a prefab. So to do this, we go to the prefabs folder, we drag the portal area and drop it here. Notice that the portal area, different than the box, the door, and the pressure button, it doesn't contain an image, it doesn't contain an icon, and this is because the portal area is something abstract. It's something the players can't see, only the developers. That's why we see this green square here, because that's the box collider, and that's what we have to worry about the most here. Okay, so we're going to work with wall 1 now, which is this one. If we drag and drop the portal area inside wall 1, we're going to have more or less the same effect. Okay, so it's going to be taking the place that we want. However, we need to divide this into two parts. So again, we're going to select this wall. Let's reduce its size, so it's going to be more or less in this position. Now we're going to duplicate this wall. So right click and choose duplicate, or hit Ctrl D and Command D, and we adjust the size of it. Okay. Remember, this is one technique to do this. There are other ways to do this. There are other more complex ways to achieve the same effect, but we want to keep things straightforward and in a way that it makes sense to you. Okay. So let's look here at wall 1. Okay, wall 1 is looking like this. We're going to give it a little more space so we can see this area. So we work with wall 1, then this one, we're going to add it as well. Okay, it might not be used in this level, but still we can add this. Okay, so we drag and drop the portal area. I think it's decent here. Wall 3, let's see which one it is. It is this one. We drag and drop inside the wall 3. This is very important because once we drag the prefab here, even though we define the portal area to have a scale of 1, 1, 1, once we drop inside wall 3, it's going to take this size that we used of 1, 9, 30. Okay, notice that if we drop a portal area somewhere that is not inside another game object, it's going to be a square. Okay, this is a very interesting thing for you to see. But if we drop in a game object that is scaled, it's going to scale as well. Okay, so wall 4 is this one. Once again, we drag and drop here. So, and notice that this one is going to work on both sides, okay, because the size that we modify for the box collider, this 1.01 that we made, it increases in the axis and equally to the positive and the negative side, okay. It's like it's a center. You kind of adjust the size based on the center of the box collider, okay. So we go again to wall 5. This one should be easy as well. We drag and drop. Alright, then wall 6 and wall 7. All of them are now with portal areas. And there is one important thing to talk about here. Notice that the portal area, okay, if you select it, its size on X is 1.01. Okay, and the X-axis, as you can see here, is this one. Okay, so with the perspective of the camera right now, it's moving from the left to the right. Okay, so if you look at this wall, it makes sense. Okay, if we increase the come here. If we increase the portal area in the X-axis, it's going to increase its size from the left and to the right. Okay, that's fine. However, if you go to wall 4, for example, the wall 4 is on a different angle. So if you look at this, okay, if you look at this icon here, you're going to see that this is the Z-axis, the depth axis. But if we work with Z here in the portal area, it's going to still increase in the Z area, but we are working with the X, and this works. Okay, this is happening because wall 4 has been rotated. When we made it, we changed its rotation to be 90, so it's going to be in a different angle. Okay, but still we have a little logic on Unity that is going to make the portal area to still respect using the X-axis. Okay, so if we change this horizontally, it's going to make sense, okay, because the wall 4 originally was like this, okay, and that's why if you change the scale, it's going to work correctly. Okay, we're just rotating things, and the scale on portal area is local. Okay, the key name here is local, right? Now we press revert just to change it back to the original state, and now that we have this level filled with portal areas, we need to work on a logic for knowing if the player is shooting at these portal areas. The logic for knowing if the player is looking at a portal area is going to be very similar to what we did with the grabbable object. We're going to perform a raycast. So at all times while we are playing the game, the player is looking at some direction. And once we press the mouse button, okay, and assuming that the player isn't holding a grabbable object or isn't dropping one, for example, then, well, we should perform the raycast and then spawn a portal in the wall that we are looking. So here in Mono, we need to take a look at the code that we did. Okay, so we made the clicking logic for grabbing objects and shooting portals. So if the grabbable object is different than null, then we're going to release, or not. If we get this grabbable object, then we're going to hold it. So at these times, okay, if these two conditions they are met, then we shouldn't throw a portal. Okay, we don't want the player to grab an object and then throw the portal simultaneously. So well, we want to avoid this. So we're going to make a variable that is going to help us with this. So we're going to type bool interacted with object, and we're going to set this as false. Okay, this is going to be a very simple variable that is basically going to tell us if we can or we cannot spawn portals. Okay, so if we release a grabbable object, we're going to set interacted with object equals to true, and here if we start holding an object, then we're going to set interacted with object equals to true as well. Okay, and notice that this is going to work only in a single update call. Okay, if the player releases the object in the next update cycle, interacted with object is going to remain false, and then we are able to throw a portal. Okay, in this call here. And now we have to make another group of code, another conditional block, so we can check if the player is pressing the mouse button, and then we're going to spawn a portal. We could do it here, but I think it would get a bit messy, so it's interesting to make another section. So let's type here logic for spawning portals. So first of all, we need to see if the player interacted with object. So we're going to type if interacted with object equals to false. And we can already check if the player pressed the mouse button. Okay, so we can add here a AND. Okay, these two characters together, they represent the operation AND. So the two statements that we make, they both need to be true. So interacted with object needs to be false, and at the same time input.get mouse button down 0 needs to be true as well. Okay, so this is going to return either true or false, so that's completely valid. So if this is happening, we want to print that we can spawn a portal. Okay, so debug.log, we can spawn a portal. Notice that we could already start by writing the code for performing the raycast, but it's interesting to do things step by step. Instead of making 5 different things and then checking everything together, we can work on one of them each at a time, okay, each at a different time, so you can see if something that you did is wrong. So I'm clicking, that means we can spawn a portal, we can see the message here, but if I grab one box, notice that we can spawn a portal didn't print. Okay, if I release, it still didn't print. So every time I'm interacting with an object, I can't spawn a portal. But if I click and I'm not looking at an object, then it's going to print the message. Okay, so this is great, right? And we're doing this because we want to keep things simple and just use one button for whatever we are doing right now. Okay, so since we can spawn a portal, and let me just change the order here real quick. I'm going to put the mouse in the beginning, then interacted with object in the end. Okay, so we can spawn a portal. Alright, so what we want to do is to perform a raycast now. And different than what we did with the grabbable object, we're going to make a raycast with no limit of length. Okay, because the first one, if you look at the raycast that we did, there is a distance that this ray is going to use, so we can define how far it can go. Okay, we made a very short distance, so the player only grabs objects that are very close to them. In this case, it needs to be different, okay, because we're going to shoot a portal. So here, what we're going to do is we're going to type raycast hit. Okay, the signature is going to be very similar to what we did before. Let me also add a comment here, perform the raycast, and we're going to add if. Then we're going to make the physics raycast question here. So physics.raycast. Right? Now, the first parameter, actually the 3 parameters that we're going to use are going to be basically the same to what we did before. So the first one is transform.position. It's the origin of the ray. The second one is the direction and of the raycast. So we're going to use the player camera to this. Here we type player camera.transform.forward. And the third and final parameter is going to be saving the raycast hit information in this variable. So in the end, we type out hit. Okay, so if this happens successfully, we should be able to look at an object. So we're going to type debug.log, and then I'm going to type hit.transform.name, so we can check the elements that we hit. So we're going to save this, we're going to wait for this compilation to be finished, and we're going to press the play button. Okay, so here we are walking around the level. If I click, it printed the name of the floor. If I look at the button, let me try to look closer here, it printed the name base of the button. And if I look at the wall and click, notice that it's printing portal area. Okay, pay very close attention to the console here. So if you look at a corner, you might not get the portal area, which is okay, alright, because see, we are printing here wall, because we don't want to spawn portals in that far position. Okay, we just want to use some very nice and free areas that we can shoot portals to avoid making this game more complicated. Okay, so we're able to get this portal area printed. So now this is great. Okay, we have the portal areas working. We are able to define where we are, well, that we get these portals. And one important thing when we perform the raycast is to get the hit position. Okay, because we need to get that information. We need to get the exact place where the raycast hit the collision area of our portal area, because that is where we're going to spawn our portal. Okay, so to get this, we need to use hit.point. Okay, and if you look at the summary that we can see here in MonoDevelop, it's the impact point in world space, this is important as well, where the ray hit the collider. Okay, this is going to be very important, so we need to keep track of this position. If we print its message, we're going to see how it changes through the game. Okay, so let's wait for this to be finished. We can press the play button, and for instance, if I go to this wall and I look and I click, we get this position, minus 13.81392. Okay, and you notice that it doesn't matter where I click, X doesn't change, because this is the hit point in the X axis. This is not going to change. Y might change if I look up or down, and Z change if I look right or left. Okay, the important thing is we're getting the right points here. Okay, so we have these positions, and also we need to make sure that we're looking at a portal area. So we need to put a condition here, just like we did with the grabbable objects. So we type if hit.transform.getComponent of type portal area. Okay, and then we open close parenthesis. If this is different than null, then that means we can spawn a portal. The spawn position is going to be vector 3, and then let's name this spawn point equals to hit.point. Okay, and once we get this, we should be able to move forward to spawning a few portals. Before we use the final art for the portals, we need to define some placeholders here. So we're going to make some very simple objects here. I'm not even going to use the level game object. So we're going to right click, choose 3D object, then we're going to choose cube. Okay, so we're going to have a very simple cube here in our scene. Let's move it to the position 0, 2, 0, so we can see it clearly. And what we're going to do with this cube is change its size. So I'm going to change it to 2 on X. On Y, let's use 4. And on Z, let's use 0.1. Okay, it's going to be a very, very thin object. Now we need to give it a color. So we're going to take this moment to make 2 colors for the portal, because we need a portal for the in and out. So I'm going to right click here, choose create, then material. And I'm going to rename this material as portal 1 material. Okay, we hit enter, and the color that we're going to use, well, it could be any of those, but I'm going to start with this tone of yellow. Okay, so I'm going to drag this and drop here, and I'm going to make another one. So we right click, create material, portal to material. Let me just adjust the name here, and I'm going to change this color to a tone of blue, like this one, for instance. Okay. So we should have 2 materials that we can use for our portals. So I'm going to get this cube and I'm going to rename it to portal. And in the project folder, I'm going to open scripts and make a script for this portal. So right click, create C# script. It's going to be named portal. Okay, we hit enter, wait for the compilation to be finished, and we're going to drag this portal script here. Okay, and since we're already working with this script, we need to add 2 public fields here, which are the 2 materials that can be used in this portal. So I'm going to come here and I'm going to type public, then this is going to be named material, we open and close brackets because this is going to be an array of materials, like a collection of materials. It's going to be a variable that can store multiple values inside it. And then I'm going to name this portal materials, and then a semicolon. So we can save this, and if we go back to Unity, we wait for the compilation to be finished. And here in Portal script, we have this portal materials. So I can expand this, and then we're going to see this size field with a number. If I set 2, we're going to dynamically have 2 fields so we can drag the materials that we made here. So I go to the materials folder, we drag Portal 1 material here, and then Portal 2 material there. Okay, we're going to use those like this. Okay, and we're going to work on the logic for changing the materials later. But now, when you start the game, there are no portals available. Okay, they are not appearing anywhere. So the portal needs to be transformed into a prefab. So the first time we try to spawn a portal, it's going to be instantiated, and in the other ones, we can simply change its position. So in the project folder, we're going to prefabs right here. I'm going to drag this portal and drop it here. Okay, so we have the portal game object. Now that we did this, we can delete the portal, and we're going to do something different now. The player needs to have a reference for the portal prefab. Okay, right now we just have the grabbing distance, the throwing force, but now we need to have a reference with the portal so we can spawn it. So what we're going to do is, we can close the portal script, we can close the game scene controller for now, and in the player, we're going to add here in the beginning of the code a public game object portal prefab. If we save this and go to Unity, we're going to see this field here, and you're going to notice now that we are mixing some variables of different kinds. So this first one is related to the portal, and the other two are related to grabbable objects. So if you want to keep this thing a little more tidy, a little more organized, you can type this. Okay, so above the portal prefab, we're going to type header between brackets like this, open and close parentheses, and I'm going to type portal. Okay, I can copy this and paste it here on the top of the grabbing variables, and I'm going to type grabbable objects. And if I save this, this is not going to impact your gameplay, but it's going to make the player component here more tidy. Okay, so we have some label that is going to define what are the names of the things that we're working with here. Okay, so we need a reference to the portal prefab. So I'm going to drag the portal prefab, which is this one, and drop it here. Okay, so the reference is saved. And now, how do we instantiate that portal? How do we make it appear in our game? We have to go back to our code and to the moment where we spawn a portal. So we have this here. Vector3 spawn point equals to hit dot point. Okay, so how do we spawn that portal? We need to instantiate that prefab, okay, because we just have a reference to it, but there are no instances in the game, and we have to spawn this. So what we're going to do here is game object, we're going to name this portal object, equals to instantiate, this is a method call, and between parentheses we're going to pass portal prefab as a parameter. Okay, when we do this, we're going to have the portal object spawned, and now we can type portal object dot transform dot position equals to spawn point. Okay, once we do this, we can save this. We can go back to Unity and give this a try. So let's wait for the compilation to be finished. And once it is, we can press the play button. Okay, so here we are. And if we click looking at a portal area, we spawn a portal. Okay, so everywhere we click, we're going to see this yellow element. Of course, we're going to change lots of things in here. Okay, we can spawn lots of portals like this. However, we already know how to instantiate objects. Okay, we just click and look. But of course, we just want to instantiate 2 portals. It's going to be the maximum value, because if you enter one of them, then you're going to come out in the next one of them, in the other portal. Okay, so we need to work on this logic. Now, we go to the player, and we need to make a private field here. That's going to be a private. Then we're going to make a list of portals. Okay, so we're going to type here list, and we're going to type the lesser than sign. This is going to be named portal, because it's the portal class that we created. And then we're going to name this as portals. And in the start, we have to initialize this portals object, okay? Notice something. In the portal prefab that we made here. Let me open the script. We made a portal materials variable that is an array. Okay, that's why we have these brackets here. So this is one type of collection. It's a very simple one of them. We have to define its size. It's going to be fixed, and just like we saw here, okay, I set it to 2, and then I put these portals, and then we simply put the elements here. However, we can use lists. Okay, in this type of list, this generic list, I can add elements with a defined class, which is portal, and it can increase in size. Even though we're just going to have 2 different portals, it is interesting that you see all of the options available for collections. Okay, and in this case, we have to initialize in the start method. So we type portals equal to a new list of type portal. Then we can simply open and close parentheses. Okay. You can do it simple like this. So we made the portal list, and now we need to check if we should spawn a portal here. So to help us work with this, we should make a method that is going to help us. Okay, since we already know where the spawn point is, we can make a method called spawn portal, and between parentheses we can pass hit.point as a position. Okay, and also we need to print. We need to pass the portal area as a parameter. So we can pass, besides the point, we can pass hit.transform.getComponent of type portal area. Even though we don't have that method yet, we're going to create it right now. And the important information that we did is exactly what is the portal area. We're going to need that information. You're going to see why shortly. And what is the hit point. Okay, so I'm going to cut these 2 lines here for now. Okay, so this method, this logic in the update method is going to be very simple. And here we're going to make our spawn portal method. So private void spawn portal. The first parameter is going to be vector3 hit point, and the second one is going to be portal area, then area. So we open and close curly braces, and we can already paste this here. Okay, let me rename this as spawn point. Okay, and now if we save this, let's see if it's still working as before. Okay, it should, because we just moved the method and we moved some lines of code inside that method. So if we click, we still see our portals. That's great. Okay, and now we need to keep track of all the portals that we have. So we only instantiate a new prefab if we don't already have 2 portals in our list. So we need to type if portals.count, this is a property to get the size of the list, is lesser than 2, then we can instantiate a portal. Okay, and one important thing here, otherwise this wouldn't work. Once you instantiate a portal, you need to add it to the list. So we need to type here, we need to get a reference to the portal class. So we type portal equals to portal object dot get component of type portal. So we get that reference. And finally, we type portals dot add, and between parentheses, what we just got, okay, the portal variable. So this is going to keep track of the portals that we have, and we're going to have only 2 of them. So if we go to Unity and then wait for a little bit, okay, so apparently we have one issue here. Let's check it out. We type portals dot add, and yes, apparently it went plural here, but it's just portal, okay, just one, right? So let's wait for the compilation to be finished, and if we try to play the game now, we should be able to spawn only 2 of them. Okay, so 1, 2, and if I click again, I am unable to move them. So the logic for swapping the portal positions now is we need to keep reference of what was the index of the latest portal that we added, okay, or keep track of what portal we are working on. So we can type here private bool spawned first portal. Okay, this is going to be very useful for us. And we're going to start by setting this as false, okay, or we can just type anything here. So this is how this is going to work, okay, so we're going to add an else here. Okay, so we have portals.count as less than 2, then we spawn the 2 portals. Then, if we already have 2 portals in here, we need to get the correct portal and set its position. So we're going to type portal, and then let's name this portal as well, or current portal, equals to portals I'm going to open and close brackets and then add a semicolon. Just like we do with arrays, we can get an element from a collection by using these two brackets and then passing an index, okay? And it's a simple number, and indexes are zero-based. So if we have a list that contains 5 elements, all of the indexes that we have are either 0, 1, 2, 3, and 4. See, so we only have a defined amount of portals. We only have 2 of them. It's going to be either 0 or 1, okay? So the first portal that I'm going to check is I'm going to type spawn first portal, and I'm going to ask a question. So if we spawn the first portal, okay, if we just used it, then index is going to be 1, because we're going to work with the second portal. Or we're going to set it as 0. Okay, this name might not be the best name we can use. We should use something different here later, okay, but basically we just want to keep swapping between the variables 1 and 0. We could change this name to something like should use first portal, okay, once this happens. And here at the top, we set this spawn first portal to should use first portal, and we can start this as true, okay? So this is going to be the current portal. And finally, we need to set the portal position. And there's a smarter way to do this, okay? What we're going to type here is, we're going to type portal, current portal. Okay, you're going to understand what's happening here. I'm defining this variable outside of this if block because I'm going to set it to be something based on what we have here in these two conditional blocks. Okay, so here, instead of defining another variable by typing portal, I'm going to remove this. Okay, so what I'm going to say is current portal, the one that I defined here, is going to be this. Okay, and here in the else part, we do the same thing. So we define a variable outside of this if-else block here, and depending on the condition where it was, we're going to set current portal to be something. Okay, so in this case, current portal is going to be a new prefab instance, and in this case, current portal is going to be a portal that we already used. All right, and after we do these two things here, we're going to get this line. I'm going to cut it from here. Okay, I'm going to tidy this up a little bit. I'm going to paste it here, and I'm going to change this portal object to current portal. Okay, also here is going to be current portal. We do this because from here and to the we're going to add new lines of code here. So for here and beyond, we don't want to know if the player instantiated a new portal or is just using a previous one. Okay, we're going to change the position of the portal. We're going to change how it works by just well, writing new lines of code. Okay, so we're going to save this. Let's go to Unity and wait for the compilation to be finished. And after this is done, we press the play button. Okay, so here we are. I'm going to spawn one portal here, then the second one, and if I click, I'm going to use that second again. Okay, so we are using the same portal. So this is something that we have to adjust. Okay, what we have to do here is, in current portal, we say should use first portal, then we ask a question. If this is true, the index is going to be 0. If it's false, it's going to be 1. So this is a ternary operation. Instead of making a huge if-else block, we can make things very simple. We pass the Boolean variable, the question that we want, then the question mark, and whatever is between the question mark and this column is going to be the result if it's true, and whenever it's left, it's going to be the result if it's false. And when this happens, we need to reverse the value that is stored here. Okay, so if this is true, we want to set it as false. If this is false, we want to set it as true. And a simple way to do this is to type should use first portal equals to exclamation mark should use first portal. This operation here is basically going to reverse whatever Boolean variable we have here. So if this is true, it's going to be set to not true. If it's so, it's false. If this is false, it's going to set to not false, which is true. Okay, you read the exclamation mark as a not. So let's save this and let's try that again. Wait for the compilation to be finished. Then we press the play button and we can try that out. Okay, first one, second one. If I try another one, I got the first one that was here. If I click again, I move that. Okay, so we move the portals in pairs, okay, which is the exact logic that we wanted to achieve, which is great. Okay, and now that we have this, we need to adjust the rotation of the portals. In order to make the portals to face the exact area, okay, the proper position, in the proper direction, we're going to use a mathematical concept. It's going to be very simple in terms of code. Okay, it's going to be very simple, but we need to make sure that we understand properly what is happening here. Okay, so to do this, I'm going to do a very rough draft here in the scene. Okay, so let's make a new object. I'm going to make a cube. You don't need to make these things, it's just for an example. Okay, so I'm going to make this one like this. So 0.14. Okay, so this is imagine this is like a sheet of paper. Let me also add a light here to make this easier to see. So great, okay, we have much more light here. And this, imagine this is simply a sheet of paper. Okay, imagine this is the wall. So let's also rotate it by 90 degrees here. I'm going to add another element here, but instead of imagining this as a wall, it's going to be array. Okay, so there's going to be 0.1 as well. Let's make this a bit taller, like this. Okay, so we have this cube. And then let me rotate it a little bit more like this. Okay, so I think you can imagine that this is a ray that it's coming from a point and going towards this wall. Okay, so it's like I'm just drawing in somewhere. Okay, so this is what happens when you try to throw a ray. Okay, so there we go, 0.1, 0.1, and another value. Let me make this ray red. Perfect. So whenever we hit a certain surface, like it's happening right now, we get this hit point. However, there is another information that is very important. We also get a normal. A normal is a vector. Okay, it's a vector 3 element in Unity, but you need to imagine it as a direction. It's like an arrow that is coming out from the surface, that it's going to have 90 degrees coming out of the surface. So to show this better, let me just adjust this. Let's put 0 here and 90 here. Let's change this color to something like this. So if you hit this little sheet of paper like this, you're going to get a normal that is going to come out from the cube. Okay, it's going to be more or less in the same place as the point of contact here, but it's an arrow. Okay, imagine this is an arrow that is pointing to this direction. It's like we are pointing to the forward of the area that we just hit. Okay, we get exactly this information. Now, what we can do as well is move this normal inside this cube. If this area was a little bit rotated, if it was like this, then the normal would rotate as well. Okay, it's like the forward direction of the surface that we hit. This is very important, especially if we are working with rounded elements or curved elements, because the surface is not always going to be flat like this. Okay, you might be trying to collide with a sphere, and the important thing is you're going to need this normal vector that comes out of that sphere in the proper angle. Okay, so it's a bit complicated to understand it. You might need to search for some extra material online, but still it's very important for you to use that and remember this concept at all times. The normal is going to point outside of the surface that you're using. So now that we know these things, we should go to this portal, to the spawn portal method, and improve our signature. We need to add one extra parameter here. So let's go to the part where we call that method, which is here. Okay, we pass hit.point, but we should also pass hit.normal, and then add a comma here. So we're going to have 3 parameters: the point of contact, the normal of the surface, and then the portal area. Okay, and then we go down here in the spawn portal and we're going to add vector 3 normal. Okay, and finally, to change the current portal so it's going to be facing the correct area, we need to type current portal dot transform dot forward. Okay, so the forward vector of the portal is going to be the normal. So we're going to save this. We go back to Unity. We're going to wait for this compilation to be finished, and we can test this out. So I'm going to press the play button. Here we are in the scene. If I spawn portals in this wall, it's going to work as before, okay, working as intended. But if I click here, it's going to be taking the exact area that we wanted. Okay, and what we can also do is we can spawn a portal area in the ceiling. Okay, so while the game is running, we can try this test. I'm going to select the ceiling. I'm going to drag this portal area and drop here in the ceiling. Okay, so we have this box collider. We need to increase its size on Y. So I'm going to use 1.1. Okay, I think this should be enough. Probably is. And now if you come here and you look up, you're going to spawn portals in the ceiling. Okay, so you can actually make a portal here, and as you have the portal in the ceiling, we should be able to make a logic to enter this portal and fall through the ceiling. Okay, so let's go ahead and adjust the ceiling. I'm going to come here, drag a portal area, drop it in the ceiling. Okay, so this is what we have right now, and we're going to change Y to, we're going to basically change the numbers that we added here. So this is 0.9 and this is 1.01. Okay, so it's a very thin area that we can shoot portals on. So we are able to make these portals to rotate to whatever position we want and get some interesting results from this. And now that we have this, we need to work on the teleporting logic. If we enter a portal from one side, we need to exit on the other side. To be able to enter portals and then come out in the other side, we need to go and select the portal and drop here in the hierarchy, and we need to adjust the box collider. Right now the portal is physical, as we talked before. If I walk through the portal, I'm going to collide physically with it, and I'm not going to be able to move forward. So this is something that we have to adjust. And to do this, we simply go to the collider and mark the isTrigger property. So this is going to be a trigger collider. We just check for overlaps. If the player touches the portal, then we should be able to, well, enter it. Okay, and since the portal is very thin, I think it's safe to say that we have some nice values here for the portal. Okay, now we need to go to mono, and we need to use the onTriggerEnter method, because we need to keep track if the player is touching a portal and if they should come out on the other side. So here, what we have to do is type in the onTriggerEnter method, if otherCollider.getComponent of type portal is different than null, okay, that means we've entered the box collider, okay, the trigger collider of that portal. Now, let's save the reference to this portal. Okay, so portal, collided portal equals to otherCollider.getComponent of type portal. Okay, so we have a reference to it. Now, we need to know where the player is going to come out, because the portal that we are colliding with might be the first or the second. So what we need to do here is type portal, and then let's name this exit portal. Okay, exit's much better name. Let's name this to enter portal, and this one to exit portal. Is going to be, now we need to ask if enter portal equals to portals, then we open bracket and type 0 as the index. We're going to use the ternary operator. We're going to ask if the portal that we just entered is the first one. Okay, so we add a question mark. If it is, then the exit portal is the second one. So portals, then open bracket, 1, close bracket. So if this is true, okay, we read it like this. If this question is true, then we're going to return this. Else, so we add the column here. Okay, so else, whatever is going to happen is we're going to use portals 0. Okay, so with this tiny line here, with this very simple and short line, we're able to tell what is going to be the exit portal. And we have to teleport the player to that exit portal. Okay, so what we can do here is simply type transform.position equals to exit portal.transform.position. We're going to save this. Let's go to Unity and test this out. There is a better way to do this that we're going to do shortly, but okay, let me press the play button here. So I'm going to put a portal in this wall, in another in this one. So if I touch this portal, I'm going to come out on the other side. Okay, so let's try that again. I'm going to enter this one, and let's see if that happens. Okay, and we come out to the other side. So there are some adjustments that we have to make sure that this is going to work properly. So the two things that I want to do is I'm going to grab the portal back to the hierarchy. Okay, so we have the portal here. Let's increase its box collider just a little bit more in the, let me check, in the z-axis, I think. So see here, yes, right now it was set to 1, so let's set to 2 to make this a bit larger. Okay, in the z-axis, I'm going to press the apply button, and when the player comes out of the portal, we need to kind of define an area where we are going to be spawned. Otherwise we would be entering the portal back again. Okay, so what's happening is this. Imagine I'm entering this side here. Once I enter this portal, I am automatically teleported to this side. However, I'm going to still be colliding with this portal, so I'm once again automatically teleported to this side. So we're going to be teleporting several times because of the on-trigger enter logic. So instead of teleporting us to the exact place where the other portal is, we need to add a little offset. So the player is not going to be immediately where the other portal was. So to do this, we need to adjust this logic a little bit. So we're going to type exit portal dot transform dot position plus exit portal dot transform dot forward. Okay, this is very important. Okay, we need to use the forward vector of the exit portal so we don't come out exactly where it was before. So if we save this and go to Unity, we can wait for this compilation to be finished. And now if we press the play button, okay, here we are. Let's add two portals once again. I'm going to add this one and this one. If I walk here, if I touch the portal, I'm on the other side. Okay, so we can just walk in here. Once we enter that, we are on the other side. And the opposite works as well. Okay, so it is much better now. We don't have any complications with the collision, and it's just working like magic. Okay, this is just great. Now there's another situation that we have to be careful with. If I spawn a portal here and another one here, and then walk like this, notice that it's not the exact effect that we want, okay, because they are in different rotations. There's a 90-degree offset between them. So if I walk here and I come to this side, I should be facing this area. And if we have two portals side by side, if I walk here, we're going to have this sort of infinite loop, okay, because I'm entering this portal and coming out to the other side facing the same direction. So we need to adjust this. For the teleporting logic to fully work, we need to make some advanced adjustments in what is implemented in Unity. So I've pre-written this code, I'm going to explain that to you. We need to adjust a few classes that already come with the package. So we need to open the first-person controller script, which is this one. And we also have to open the mouse look script. Both of those can be found by just typing the name here, and then you can just click and the scripts are going to open. Okay, so the first thing that you might want to try when you're making this game, and it is a very nice try, is go to the player here where we set the position of the player to be at a certain point after the portal, is to type transform.forward equals to exit portal .transform.forward. This is perfectly fine. However, the logic that already exists for the first-person controller would override what you already do at all times. So it seems like this is doing absolutely nothing. Okay, the camera won't change, the player won't change. It's still going to be facing the wrong way like it is right now. So what we have to do is we have to go to the first-person controller and we need to make a new method. What I created here was a method called copy rotation. We do this because we want the first-person controller to copy the rotation of whatever we're going to pass here, and in this case it's going to be the portal. Okay, so it's going to copy the rotation, and we're going to recall another method inside the mouse look object. Okay, this is the thing that is controlling our camera. Okay, if you remember, if you go to Unity and you take a look at the player, we have that first-person character, but as we press the play button, okay, after the compilation is finished, then there we go. And if you look at the first-person character, there is a camera inside it, so there is something that is controlling it. Okay, so player is the first-person controller, and first-person character is the camera. Okay, so we have two things going on here. So we make another method called copy rotation inside mouse look, and we're going to pass the transform of the first-person controller and the target, which is going to be the portal. Okay, so you basically copy and use these lines in your first-person controller class. Okay, you can paste this whatever you want in this class. And now to the mouse look, we have the copy rotation again. It's a public method, it is void, it is copy rotation, and then we set as parameters transform character, so we're going to pass the first-person controller here, and transform.target, which is the thing that we're going to copy. Now what we're going to do is we're going to set m_character target rot. So the target rotation of the character is going to be the target that we passed as a parameter dot local rotation. Okay, this line would be enough if we are just working with portals in the walls. But as we have portals in the ceiling, there might be some issue if you don't take a lot of care with this. Okay, so we need to make this a bit simpler. We go to the m_character rot, and we're going to call a method called quaternion.euler. Okay, this is a bit of an advanced topic in Unity. You might want to read about this at some time, but basically rotations, they are defined as quaternions. They are not normally defined with 3 variables. Even though if you go to Unity you can see that there's X, Y, and Z, there are some very advanced mathematics going on under the hood to adjust these numbers to the proper values. But quaternions, they actually have X, Y, Z, and W. There's a 4th hidden variable in here. But you can make a conversion by typing quaternion.euler, and we're going to pass here a few parameters. The first one is going to be 0, and this is the key here. Once you enter a portal, we are not going to preserve the rotation in the x-axis, because otherwise the camera would be a bit weird. Okay, and then the second parameter is the character target rot.eulerangles.y. We can preserve the y value, and we can preserve the z value as well. Okay, so basically quaternion.euler, first parameter is 0, second one is eulerangles.y, third one eulerangles.z for the character target rotation. Okay, so we can save these 2 scripts once you finish writing this logic. And now back to the player, we're going to call that a copy. Okay, so we type transform.getComponent, and instead of going and typing straight ahead first person controller, we need to access its namespace first. So we type Unity standard assets dot characters dot first person controller, and we open and close parentheses. Then we call the copy rotation method that we develop, and we pass exit portal.transform, so we can copy the rotation of the portal. So we can save this and go to Unity, and we can give this a try. We press the play button. Okay, so here we are, and the first test is I'm going to make a portal here and another one there. It should be very simple. Okay, we simply walk at one and come out from the other. That's fine. Now if I put one here, one portal here, and I use this other one here, if I enter it, I'm going to exit facing the correct area. Okay, so it's looking like this. Notice that if you enter sideways, you're going to be facing forward once you exit it, but that's the price we have to pay for now, so we don't worry on making some very complex logic at this point. Okay, we want to make only to adjust the game so it's going to work, so later we can extend it to do something else. And if we put one in the ceiling and another one here, if I enter, I'm going to fall from the ceiling, and rotation is still working perfectly. Okay, so you basically enter and you come out from that ceiling. Okay, so a very simplified system that works well. And if you are thinking nicely, you can now press this button, and while this door is open, you can shoot another portal there. Okay, so I can do this, even though I can't run and reach the end, I can enter this portal and come on the other side and beat the game. So that's another solution for this level.
Hey everyone, thanks for watching this course. If you want to watch the rest of the course, the link is down below. Not only will you get the access to this course, but you'll get access to a lot of other courses in a huge bundle, and it's on sale today. So buy it before the sale ends. Thanks for watching, and I'll see you in another video.